Hello class, I've created an application similar to D'Artagnan's which finds the distance between two cities based on the distance between the cities and the angle of where I am positioned. So here is the prompt for this application. I am standing on a box in Dover, Delaware. The state of Delaware is notoriously flat. I can see Newark and Milford from my box, and using my handy dandy magnifying glass, I can accurately judge that Newark is 38.2 miles away and Milford is 17.7 miles away from my box. By pointing my handy dandy arms in the direction of either city, I am able to determine that the angle relating my position on top of my box to Newark and Milford is 179 degrees. I have to find the distance c between Newark and Milford using the law of cosines. So the law of cosines is c squared equals a squared plus b squared minus this third term, which is 2ab cosine theta. Alright, so we're going to put our knowns into this box that's blue. So the distance between city A, which is Newark, and Dover is 38.2 miles. The distance between Milford and Dover is 17.7 miles. And remember, using my handy dandy arms, I find that the angle is 179 degrees from my box in Dover, Delaware. The first step I'm going to do is square A and square B. So here we have B10 and D10, and within that cell I have an equation that references the corresponding cell and then squares it. So B7 squared, and then we get the results being roughly 1500. Same deal goes for B10, that is roughly 300. This F10 sums together the previous two boxes using sum equation. Okay. Now, we want to figure out what the value of this third term is. Alright, and this is the most complicated part of the application. So we are going to multiply 2 by B7, which is that right there. Okay, so when I click on it, you can see. So 2 times B7 times D7, and then I'm going to find the cosine of whatever angle that is. And because Excel always deals with radians when it comes to angles, we have to convert this degree to radian. So that's why we have this radians function here, which references F7. So going backwards, we're putting 179 into this radians function to get the radian equivalent, finding the cosine of that radian equivalent, and then multiplying it by D7 and B7 and 2. That gives us a negative value. However, because we're actually subtracting that from the squares, we're actually subtracting a negative, which is adding. So we come up with a positive of roughly 3000. Right? Then all we want to do is find the square root of that. So I actually reference in, B16 and find the square root. So all in all, the distance between Newark and Milford is 55.9 miles. And I can verify that because I have friends in Newark and Milford standing on their own boxes, and they have their magnifying glass and they're telling me that it is 55.9 miles.